The University of Tennessee at Chattanooga is a metropolitan campus located in the heart of downtown Chattanooga and is home to more than 11,000 students and growing. This urban landscape, nestled at the foot of several surrounding mountains and bounded by the Tennessee River, is susceptible to significant flooding and water pollution. These common problems stem from Chattanooga's combined sewer system, coupled with the substantial amount of surface runoff generated by stormwater volume that cannot directly infiltrate into the extensive concrete and asphalt regions of the city campus. We thereby propose Operation Clean, capacity enhancement with landscape modification using an ecological approach for absorption and natural recharge around the engineering, mathematics, and computer science building on campus. Features of Operation Clean green infrastructure include interventions such as downspout disconnections, permeable pavement, underground cisterns, and retention areas, integrated with real-time sensor-enabled operations. With active student and community engagement, Operation Clean will implement an outdoor environmental lab highlighting the innovative green design elements of the project, complete with educational signs, a cost-friendly source of water for irrigating the greenhouse, and a retention basin, complemented with picnic tables, benches, and native plant species. Overall, Operation Clean meets the current stormwater regulations set by the City of Chattanooga for new developments, while pushing towards an inspiring future of innovative green infrastructure for stormwater management and water pollution mitigation.
The 2012 UTC Master Plan outlines the future vision for campus development in terms of buildings and land use, residential student life, campus open space, circulation and parking, transit, utility infrastructure, and land acquisition in order to promote connections to the environmental city of Chattanooga, provide leadership as an environmentally sustainable institution, build a framework for a safe and appealing campus landscape, and support technology and infrastructure to promote instruction, learning, scholarship, and service. Referencing the UTC Master Plan goals, considering the GI survey and addressing stormwater management issues around the EMCS, Operation Clean's project objectives are as follows: to reduce stormwater runoff entering combined collection systems using an ecological approach to help alleviate the city of Chattanooga's CSOs, to promote campus water sustainability by implementation and education of green infrastructure elements to clean and reuse stormwater through the process of absorption and natural recharge, to revitalize campus aesthetics through landscape modification, creating exposure to native ecology while advocating a multitude of social benefits such as encourage community involvement, enhance student gathering areas, and overall improve physical and mental well-being. Finally, to demonstrate potential use of advanced technology for effectively managing water volumes and discharge from urban capacity enhancement units such that urban flooding can be mitigated and water pollution is minimized.
Chattanooga, Tennessee receives an approximated 51 inches of rain per year. This amount of rainwater causes flooding around the UT Chattanooga Engineering Building, eroding the soil and over time the concrete. The project area around the EMCS building is about 8.07 acres, dominated by impervious parking lots, pitched roofs that are directly connected to the combined sewers, with about 27% pervious areas. Pools of stagnant and polluted water form in the middle of parking lots and fields, which may pose a danger to the community and ruins the overall beauty of the campus.
To aid in mitigating this issue, our design plan will maximize the campus's natural water absorption through the use of green infrastructure practices that will absorb, redistribute, and recycle the large amount of water runoff common during long bouts of rain. Based on site conditions around the EMCS, we identified 4 main areas to concentrate our efforts.
Areas 1 and 2 are heavily trafficked parking lots that become highly inundated during long bouts of rain. For these 2 areas, we hope to replace the existing pavement with permeable asphalt or pavers where applicable. These additions will not only reduce the amount of runoff left in the lots, but will trap pollutants within the pavement itself. Area 3 is a potential outdoor lab to be used for either academic or recreational purposes. This redesign will provide much needed green space to an otherwise gray area, allowing students a small spot to relax or study between classes. The final area of this design plan is a pond located at the very bottom of the system. Currently, this location simply collects the runoff from the last 3 areas, resulting in a swamp-like pond that only serves as a breeding ground for insects and is an eyesore for students and staff. Our plan calls for this swamp to be transformed into a retention basin that will retain and redistribute the water to be used for other purposes, such as subjects of study or watering plants on campus. A sensor system used to control the flooding and improve water quality within the basin will allow for constant real-time monitoring of how local weather affects the campus, as well as providing an opportunity for students to study the many stages of water quality.